All right, Karl, I'm going to send permissions your direction. And let me introduce you quick. So Karl Wyant is the Director of Agronomy at Nutrien. He has also served as a Vice President of Ag Science at Helia Agriculture. He is a certified crop advisor, a certified professional agronomist, and it wouldn't have popped up. Holds a pest control advisor licenses in California and Arizona. He has a bachelor's degree in biology, a master's degree in ecology, and a doctorate degree in biology from Arizona State University. And he's going to talk to us a little bit about some indices and nutrient analysis and responses. So take it away. I see your slides. Everything looks good.
Great, thank you. Thanks for that introduction. I'm sure where I have my different CCA licenses and PCA licenses has revealed where I came up in the business end, and that's Arizona, California. And what I wanted to talk about today is just some of the what we've learned out west, and really it's the next step and what we're needing on next steps really to make decisions in the field regarding how we're integrating soil health into our holistic field management. So I'll cover that. So it's a little bit of a call to action to a lot of the researchers here on the call here today, and I think shares maybe some concerns coming from the grower community that, okay, I've gone and measured things. Well, now what do I do? So I'll let me pop over to my slides here, and we'll get into it. So I think I have the longest title here that I could come up with, so enjoy that word salad. But what I'd like to talk about is just where are we going with how we measure soil health, and how does it relate back to the world we know? And the world we know is that typical soil sample where we go out and we take a Malick test, or we take a Bray, we take an Olson, and I'll spotlight phosphorus a little bit here in a second. But you know, we can take those soil measurements, we have them calibrated to different regions, and we can derive some sort of action item in terms of fertilizer management and cost management from there. So I'm going to try to stick them together, soil health and the soil sample that we all know, and we'll see where we end up. So let me jump ahead. And really just this concept we're starting to push towards is this holistic soil management. And in my view, we've done a great job with physical and chemical management. Physical management with our implements and our tools in the field, and then the chemical side where we can go grab your typical soil sample and we get it worked up, and then think about what can we apply, fertilizer, compost, manures, those types of things to manage the soil. The new frontier is this biological space. And I think, just to Jason's point, this is where we're really bringing in that soil health, because it's the living component of the soil that unites the chemical and physical measurements with those biological measurements, which are ultimately measurements of soil health. So if you look at our current paradigm, and I really had to play with the PowerPoint Venn diagram deal here to make this graph work, but I've kind of adjusted what I think is our understanding of soil in terms of holistic management, and that's lots of understanding on the chemical side. I'll show you some graphs and whatnot from Iowa that help prove that out, and then the physical side, you know, these different measurements of texture and how we can predict different water holding capacities based on texture, those sorts of things. But in that small little circle is our understanding of how the biology fits into all this, and how the biology fits into our field management strategy. And so I couldn't make that circle smaller. I wanted to, but then I was afraid it'd be a little bit unreadable for your eyes. So I think that we don't quite understand the biology piece. We know it connects a lot of different aspects below ground. And I think what's worth pointing out here is that it hasn't been until recently that we've had this ability to measure the biology of the field and measure it economically. There's been a huge data revolution, and really has picked up a lot of steam in the last 10 years. It's been exciting. I remember, you know, when I was in grad school, going to get the DNA measured in the soil, you know, it was a good chunk of your grant monies was measuring for the microbial DNA. Now, with our different revolutions of data management and techniques, now it's not quite so expensive. So these new measurements are becoming more available, and I think it's an exciting time to be in soil science and in sustainability science, and trying to measure these different aspects of the Venn diagram. So I'll show you a real world example of a soil report. And I chose this one. I'm not going to call out who the lab is, but I chose it because it's colorful and it's easy on the eyes instead of a bunch of numbers. But just to point out, you know, what we're sort of all used to is taking a soil sample and getting data back. Here's some data on the pH, so we can use that to write lime programs or sulfuric acid programs, depending on where you're at. Here we go into some of our nutrients, our chemical-based pieces of the soil portfolio. Here's our phosphorus, 9 parts per million. Here's our potassium. And we're getting a lot of useful data here. Good physical data. Here we have CEC. We have the base saturation percentages and lots of chemical data, all these different tests to look at the nutrients and make some sort of rating from that, and then do something with it, right? And I'll talk about that in a second. One struggle we've had is folks, they want to get into soil health, but here's their program. Here's their soil sample program. You know, we sample in the fall every 2 years. We sample in the fall every once a year. You know, everyone has their different recipe book, but the struggle has been integrating new information streams into the sort of classic paradigm. And one of the challenges is not a lot of us aren't measuring for soil health yet. You might be able to stretch it and say this organic matter, the soil organic matter rating of 1.7, you know, this is some sort of measurement of soil health. But as Jason showed earlier, there's other nuances to this relationship between soil health and how you're managing, and there's new measurements. So we're going to need to look beyond the classic soil sampling techniques, and we'll talk about that here in a second, how we get there. Skip ahead here. My slide is frozen, so I'm hoping it resolves itself here soon. There we go. Sorry, my slides froze. So I mentioned this business as usual, you know, sort of approach from these practicing agronomists, CCAs, and growers, where we have this ability to look at our soils, and we have this ability to make some sort of recommendation, right? Where we can actually go into this is the Iowa Corn and Soybean Fertility Manual. You know, I mentioned the 9 ppm Olson's phosphate level. You know, it was 9, so it's on the low end. So I have a rating. I have low phosphate, and then I have something to do. I have pounds per acre to a pound of phosphate. So 75 pounds an acre. You know, I can make that work. I can look into different fertilizer sources, when I put it out, where I put it out, how I put it out. So it gives me a lot to do. I have a measurement, and then I have a complete recommendation of where to go next. And that's what we're all used to, whether it's, you know, potassium or nitrogen or phosphate or micronutrients. We're really used to this complete story that we can get from one measurement using very common methods for extraction. Here I have the 3 for phosphate. So if you take this a step further, we've been doing this so long that we have really nice calibrated data. Here's corn yield response in Iowa, there in the lower left, and we can relate it back to the parts per million on a soil test, and we can see, you know, where we're at on this curve, and we can make some economic decisions when it makes sense to fertilize and when it doesn't. And then, of course, we can integrate that back into our Fourhour nutrient management. You know, I mentioned that earlier, right source, right rate, right time, and right place. So we can really manage this piece, and it's easy to get the data. Maybe if you're out having to, you know, poke some cold soil, or it's really hot out where I'm from, it might not be as fun to go get the soil sample. But at least after the fact, we can take it to that final stage of making that decision from an application standpoint. So let me continue our discussion on phosphate. That's an important nutrient to me. It's one I spend a lot of time managing out here out west with our soil pHs and our low phosphate values. It's a driver of yield. So just to remind everybody, what are we doing with this phosphate in the plant? Well, I circled some of these places where you'll find phosphate, just so you can see why it's so popular with our crops. There's phosphate in the membranes of organelles. Here's phosphate in the genes that hold the plant up. It's right there in the DNA and the RNA. And then you also have phosphate on the ATP, and that's in the upper right. That's the material that plants pay for work. Here's the currency they use to get that done. So lots of popular reasons to manage phosphate, and we really have a good story on why we need to manage it from a chemical standpoint, and we can actually make recommendations. It's just, what's the next frontier? How do we integrate that biological component? So that's what I'll talk about next. And here, just to remind you of what we're dealing with on phosphate, is this small amount of the soil. If you take the total phosphate of a soil, it looks pretty good from a parts per million or pounds per acre standpoint, but from an actual plant usable phosphate, it's very, very small. So on the screen here, you'll see in a second a pie chart that sort of represents, here's what my soil test measures, and that's that Olsen P, Malick, or Bray. But of the actual amount of phosphate in the soil, very small sliver is available to your plants, and that's that pizza wedge that's in yellow, very small amount. So our goal here is, how do we start leveraging some of these different biologies of the soil, soil health, soil chemistry? How do we make more of that phosphate available so that we can make some different management decisions? And so that's this last arrow that's on the screen here, this showing the how do we make that pizza wedge a little bit bigger? And so I think one of the challenges is kind of reconditioning our understanding of phosphate dynamics. If you go through school, a lot of us are taught phosphate availability. It's diffusion based, it's supply based, it's based on temperature and organic matter. But there's been a recent review of soil phosphorus and coming from different pools and how the biology relates to that. So you have inorganic phosphate, that's the sort of the chemical sort of base of phosphorus. And you also have the organic phosphorus that's either on manure, compost, or in the organic matter. But what we're learning is that a lot of those different phosphate sources can be released through the microbial community. And so when we're pushing on this soil health, we're really trying to optimize our soil microbial communities. That's one component of it. And what we should see here is, if we're optimizing the microbial health, we should see an improvement in phosphorus availability. And so if you've ever tried to measure soil biology, it's a challenge, because it's so dynamic. You go out when it's too cold, too hot, too dry, too wet. You have different regions of your field with different organic matters. It can be challenging to measure that. And I think that's part of this future call to actions. How do we take a soil sample or sets of soil samples, say if you're grid sampling or zone sampling, and how do we relate those Venn diagrams together of biology, chemistry, and the physical components? So I mentioned there's been some new work. I just picked up a new book preparing for this talk called Phosphate Solubilizing Microorganisms. And when I read through that book, I found, wow, look at all these things in the soil we're learning. Aspergillus, penicillium, mycorrhizae, the different bacteria like Pseudomonas and Bacillus. Look at all these tools we have to help free up more phosphate in the soil, whether it's tied to the inorganic component or in that organic matter. So we know that there's a good theoretical grounding of using these materials, using these different these microbes and biology, and we can help boost those populations with our approach to soil health. So what's the challenge here? The challenge is that we get these metrics back from a soil health test, and Jason showed a couple, but it's hard to relate it to this sort of classical viewpoint of what soil tests means. So here's that same curve I showed earlier for Iowa, just kind of generalized. We know that there's some sort of measurement here on the x-axis of biological or soil health activity, but how does it relate to yield? How do we calibrate these curves by climate, soil type, and crop? How do we know what the appropriate levels are? How do we know if we're on the right track? So this is that call to integration, is trying to put these components together in a way that gives us an action item at the end. I did this to my soil, so now, and I got this measurement, so now I can make this economic decision. So moving forward, really, I'm going to go back to that Venn diagram once it clears up for you, and show you that really what we're needing, and Jason, your group is doing such a nice job here of relating these different Venn diagrams, really expanding the role of that biological component. You can see it's much bigger than that graph I showed a few slides back where it was real small. That biological component, trying to relate some sort of calibration to, like, what does this all mean and how does it relate to on-field performance? And I think that next step here is, how does it relate to the economic decisions we need to make for our farm? So what's next? I think we're going to have continued fertilizer demand and great 4R practices. This community that's at this conference has embraced the 4R practices, really optimizing nutrient management within a given framework. We also have recognition of new approaches. There's new stuff coming down the pipeline, good theoretical underpinning of those practices, lots of great work being done at the research level to try to drive this future where we're engaging all three of those circles of the Venn diagram of holistic field management. And then just that call, we need to integrate our data streams, which have been a little bit separate. You know, you have your biology measurements, you have your chemistry and physical measurements. Let's put them together and let's drive an action. And one thing that's been really exciting to see is just the developments in the ag tech sector, where folks are out using those new practices, good theoretical underpinning to try to develop some new tools and ask some new questions. So I show you an example here on the screen. This is a group called Biomakers. I grabbed one of their reports, and they're out taking DNA samples of your soil, and then they can work it up and give you an estimate. Here's this top box. That's your a general overview of your microbial community. And this sample, high biodiversity, medium functionality, and then you have just to that right is some notes on resistance, which is low. But I'll connect that back to the phosphate, and here's the same report who took all that DNA and made some conclusions. Here's what it looks like in terms of your phosphate nutrient cycling. And so they're saying here you have good phosphate solubilization, both from the inorganic side and medium organic phosphate assimilation as an indirect benefit. So really you're seeing some next steps. Here's what the microbial community is, but the next step is, here's what it's doing for you. And I show phosphate as a particular example, but here's what it's doing for you. Here's how it's impacting your different phosphate pools, including inorganic phosphate and just overall phosphate solubilization. So that next step is, okay, how does that relate to some of these economic decisions I need to make for my farm? How does it relate to my fertilizer application practices? And I think that's the next exciting step here as we build this out over time. And so I always like to say, and I've worked with growers for a long time in the soil health space, some of us are from regions where the soil health labs aren't quite as mature and sophisticated as some other regions, and they don't have that library of calibration. One place to get started is to take your best farm, the one that always does really well, your best field, and take some soil health samples there, and that could help you set some of these targets, and then you can compare other fields. If you have access to a region that's you know, maybe isn't quite as hasn't been disturbed as much as the farm, you could also try to get some samples from there, but make sure you ask permission first before grabbing them. So lots of different experimentation going on. Very exciting space to be in, but I think we're just in the next 10 years going to really solve this problem as we work the soil health into our full decision making set of steps. So here's some resources, the NRCS soil health page, and also the Soil Health Institute that Jason's is at. Great resource. If you're interested on the nutrient side, you can go to Nutrients Economic webpage in our ESN nitrogen pages, And then also that test I mentioned earlier, the bee crop test, that's a great resource if you're interested in looking at, here's my soil microbial community, a measure of soil health, and here's what it's doing in my soil, just if you're interested in exploring that. And Marie, that's my last slide.
All right, thank you. As I'm coming on here. Okay, well, I have a number of questions for each of you and some that I think you could both speak to. So Jason, if you would like to join us here, and I'll pull my questions so I can read them quickly or easily. All right, there you are. So Jason, I'll ask one for you first. Someone asked if you could talk a little bit more about how weed suppression might impact soil health. They make the example that sometimes growers choose to use tillage to manage those tough weeds. So that would probably have repercussions on soil health. Can you talk about that a little bit?
Yeah, I mean, this is not an area I'm an expert in by any means, so I might be speaking a little out of turn, but certainly I think, especially in the context of herbicide-resistant weeds that just aren't responding to our traditional, chemical management regimes, that, traditionally people have turned to tillage as a primary way of suppressing those weeds, but the research is pretty strong in that, even a little, you can undo a lot of good work in improving soil health with one tillage pass, especially a tillage pass that's aggressive enough to suppress weeds. So I think there's a lot of potential in the use of cover crops to manage weeds. But when you're thinking about the stand of cover crops you need to really do weed suppression, these are pretty advanced soil health systems. So I think we need a lot of research, but one of the things I tried to highlight in our talk is the really key role that local agronomists and that local knowledge are going to play in making sure those systems work. So I think there's a lot of potential there. I don't have a firm grasp on the science because it is still emerging, but I would say anyone who's interested in it, talk to people locally, because there's probably in your region a producer who, if not is doing, if they're not thinking about cover crops from weed suppression, they're probably growing stands of cover crops that are suppressing weeds, and they'd be a really good resource to seek out. So I think the sort of two takeaways I would say is like it needs to be addressed with a really locally relevant management system, and finding that right mentor who's done that kind of work in your region is the right approach to it. And then the science is emerging. There's a lot of interest in it. And hopefully over the next couple of years, we'll get a really good, clear picture from some research, university trial kind of studies to show that there's a good, really strong benefit there. But that's sort of my two thoughts.
Yeah. All right, I'll send one over to Karl here. So Karl, you pointed out that soil biology has been apparently left behind, which you could, surmise that has to do with technology, et cetera. So what do you think would most push that frontier forward?
I'd say the cost of the sample coming down has really opened up just these broad avenues for different groups to come in and to invent new technologies for measuring soil health. Jason, you probably remember when getting a soil DNA sample was a huge chunk of the budget. I remember that. It was like it was so high, almost unobtainable for what we're trying to get done in the field, real world stuff. So seeing the costs and the technology become more accessible, I think it's just going to keep driving this exploration of the biological side of field management. And I think we've just started scratching the surface there of what it means to us as growers and the broader ag community.
All right. Yeah, there was a follow-up question. I think it's related. Someone asked, what do you think could be, is there a reason to justify different types of funding for that kind of work? Or, is there funding missing or funding gaps? Or is it more just cost of analysis, you're thinking?
I think it's just cost of analysis. And as that cost of analysis has gone down, you've had more agricultural laboratories, the same labs that are generating our typical soil samples, they've been able to come in and actually offer some of these biological analyses, soil health analyses as a service, and that's made it a lot more accessible across these different regions.
Okay.
Yeah, if I could add to that, I think part of the answer to that question is cost. As Karl mentioned, like cost needs to come down, but it also needs to be the relevancy of those results. And I think Karl did a good job of pointing this out. Like as we build out a database of calibration curves or response curves, whatever we want to call it, around those biological results, we're going to see that investment will pay off, right? So if a test is really expensive, but it tells you the answer to all your problems, people are going to pay for it. But right now, with a lot of these tests, soil health, biological or otherwise, we often lack that reference data or that calibration data that we have with traditional fertility metrics that makes those tests a little less relevant. So as we see data banks increasing and data sharing across universities and across federal projects, building out a good database where people can build, DNA-based or biologically based metrics, I think we will see that the relevance of those measurements will be more valuable as well.
Jason, that's a great point. I think one thing that's worth pointing out here is that it takes time to build these databases. What we have on our side for the nutrient calibration curves, phosphate, nitrogen, potassium, we have time. We've been doing them a long time. We've generated hundreds and hundreds of or thousands of observations. We can make a curve. We're just getting going on the soil health space, and I think it's been really exciting the last 4 to 5 years to see this space start to become a lot more sophisticated. I'd say we're just getting going, and it's a cool place to be at.
Yeah. So there's there's a question that's probably an open-ended answer, but someone asked, is there a time frame that we can expect some kind of these measurements to be ironed out? Like you just answered it right there. Like we are on the cusp of learning what we even can learn, right? So lots of potential. So someone asked, and you could both comment on this, like how could someone measure soil biology, or how could that be monitored by a grower? I mean, are there any visual type cues, or aside from your crops doing great, but is there anything else they can turn to?
Jason, you want to grab this one?
Yeah, so like from our work, we're really thinking about respiration as being a pretty strong indicator of the microbial biology, right? So that 24-hour standardized burst respiration being a good indicator of how quickly and healthy that organic microbial community is cycling nutrients. And certainly we need the reference data to back up and underline those tests and make them a bit more interpretable. So that takes a little bit of time to build those out. But as Karl mentioned, we're seeing in certain regions commercial labs coming up to speed with pretty, relatively inexpensive ways of testing these things and building those out as analyte packages. So I think we're on the cusp of that being a viable, target in the next maybe 3 to 4 years. In terms of like really easy things, we often talk about, if it's, more of a qualitative view, things like, just a simple like shovel test looking for earthworms and that kind of stuff. You hear that a lot. It does have some merit. It's not quantitative, so it's hard to really wrap your head around as a scientist, the ultimate value of that. But there's visual cues someone can go for too. But ultimately, we're trying to think about all of these soil health measurements as being related to biology at some extent, right? So our respiration measures the microbial biology, but things like aggregate stability, which is now becoming really easy to measure with some of the emerging tools that we have. It is biologically driven, right? The microbial glue that keeps aggregates together is a indicator of soil biology. So I think all of these things are loosely biology. And they're indicators of the effect that the biology is having on soil, which to some extent might be more relevant than measuring the biology directly. That's sort of my take on it.
Jason, I think that's a solid advice. Is if you're looking to test your soil and say it's the biology directly or some of these indirect effects on improving soil biology, like improving your aggregation. If you're new to this kind of testing, that's where having a good advisor comes into play, and having a good consultant. There's probably, Jason, I see you clapping. There's probably someone in your neck of the woods who's been doing this a little while and can say, hey, go measure these 3 things. Here's what we're going to measure. Here's this is what we're going to get done. And so you really aren't poking along in the dark. You've really got a good plan to optimize the effort you're making to get that information.
Yep. Yeah, couldn't agree more. And I think the idea of having someone there who can help you interpret those results and say like, oh, I've measured respiration on 50 farms, and this is kind of the range we expect in this normal area. Your numbers look good or your numbers look bad. That's the most important piece, is the context. And it's a locally driven thing.
Yeah, that's excellent advice. And that fits right in with one of the other questions. Jason, you mentioned a bunch of different metrics for aggregate structure. Did you think that one of those would become eventually most useful, or is it a matter of picking a metric for soil? And I think you kind of answered that. It's regionally, at least, right? There are going to be certain metrics that might be more useful.
Yeah, but one of the things we've tried to do with our North American project to evaluate soil health measurements, which is still, doesn't matter how many times I say it, it still trips me up. We compared all those measurements of aggregate stability, and they're all reasonably good. We have an upcoming paper that compares and contrasts all those measurements. The one we think has the most is most viable for operating at scale is a measurement called SLAKES, and that's in our notes in that talk I just showed. But it's a digital photogrammic method to measure aggregate stability. So if anyone's measured aggregate stability with wet sieving, you know how cumbersome that is and how it just doesn't scale for commercial labs. This photographic method has a lot of legs. It's a really viable tool. We have on our website, we have a standard operating procedure for running that methodology. And we're actually, hopefully in the next couple of weeks, releasing a application for Android phones that can measure this aggregate stability. So that would be, if you're interested in aggregate stability, SLAKES or slaking indices, I think are the way to do it, because we can operate those at scale. It takes 10, 15 minutes to make a measurement versus hours with a wet sieving.
Yep, I've done those. They take time.
You just brought up a bunch of bad memories from grad school here, Jason.
All right, well, thank you, Karl, Jason, thank you so much. I just want to remind everybody who's listening in on the call that if you want to reach out to our speakers, any of them, all of their information is, well, 1 in the program and 2 specifically on sponsor directory. So those are available for you, and can continue the conversation afterward. So thanks again. I'm going to take this time now to introduce our moderator for part 2, Donnie Taylor.